So I'm going to try my best and tell a little bit sort of the behind-the-scenes story of the enterprise integration patterns. I mean, the book came out, it's like almost 8 years ago now, and so I'm very happy to see the broad adoption, and that's something we could not have anticipated when we wrote the book. But I want to tell a little bit sort of how this came about, and then also a little bit about maybe the things that are important but not necessarily written down in the book, sort of the between the lines, and then also talk a little bit about my current work or what I think can come next. So with that, it's like the past, present, and future. I want to sort of rewind a little bit into the past and take things from there. Let me make sure this works. So this is the distance past. That's me. Yeah. And as you can see, I always had a knack for loosely coupled systems, right? So that's where it all started. But sort of a little bit slightly more on topic, right? It's like, these are sort of the slides I used in maybe like 2001 something, right? Just to remind ourselves how far we've come, right? So like these days, so back then it was all about we have these isolated systems, they don't really talk to each other, and we sort of have the dream of the unified access. And today it's sort of almost the opposite, right? Today everything is connected, and we don't use the word isolated much anymore. We use multi-tenancy, right? Like it's like suddenly it's a feature as opposed to like a liability. But back then this was really one of the key problems. So sure enough, there were a number of people who felt they want to address this problem. So throughout the years, a number of different solutions came up. And don't take the years sort of too literally, but sort of roughly, this is sort of the evolution I saw. So the first idea is, of course, I want to get data from A to B. So why don't I package this data up, send it over from A to B, and then sort of reload it or synchronize it, et cetera. And while that seems sort of fairly clunky or old or whatever attribute you want to stick on it, it's actually very nicely decoupled. Right? It's good physical decoupling, it's sort of temporarily decoupled, it's system independent, right? So in some way, it actually had some nice properties. On the other hand, sort of on the flip side, it takes time, it's not sort of immediate, the systems are always slightly a little bit out of sync until sort of the next batch cycle happens. And also sort of there's usually like sort of one big pile of data at one time. But really the thing that nagged us the most was that really the two systems never sort of looking at the same representation of the data. So then the logical conclusion of that was that, hey, if we can just put this all in one database, right, then like all these synchronization problems go away because by definition, everything is stored in one place. So we can get nice reporting. It's always guaranteed to be transistent. We have transactional guarantees, right? Sort of all or nothing, two-phase commit. So that seemed sort of like the next promising way. But then it turns out it's actually very, very difficult to find this sort of so-called canonical data model or the common representation, right? Because it's different semantics. It's not just sort of mapping first name and last name, but often the fields have sort of overlapping and slightly different semantics, and it just became very, very painful. Like most of these projects, or many of these projects, spend a large portion of their time trying to find the holy grail of this data model, and then sort of, there was little time or money or patience left for the actual implementation. And sort of what we felt was sort of that while data is very interesting, we had a whole panel yesterday about sort of the value of data, that as an integration point, doing it at the data level is sort of a relatively low and raw level where it's difficult to get everything under one hand. Well, sure enough, we had another solution sort of out of our pocket. And they just say, instead of data, this should be about methods and behavior, right? We learned about object orientation now, right? So the next shiny thing. At this time, it's all about encapsulating, putting the behavior in its proper place, and sort of doing this as we go along. So now we can solve two problems. Right now, it's sort of mostly immediate, right? Like sort of, the communication sort of happens as things occur. And we have this nice abstraction sort of layered around it, right? It's all about behavior, so I can make this request through a remote procedure call. As always, we've sure enough found some flip sides of it or some limitations, which turn out we have this sort of spaghetti web of connected systems, and it's really hard to figure out what is actually going on where. And the other part is it turns out that sort of making a remote procedure call look like a local call works sort of on the technical, on the API side, right? We become very clever of just sort of hiding the underlying details. but when it comes to things like latency, or when it comes to like kind of error states or error conditions, we cannot hide those. So in a sense, sort of we painted the picture for the developer that is sort of 90% paradise, and then all the ugly stuff came later. So there's an interesting saying which is sort of, the better the approximation get, or the better the illusion is that you're trying to create, the harder it bites you when sort of the ugly stuff comes out later, right? So there's a little bit of a talk. Sometimes people call it sort of honest representation versus sort of like illusionary representation, right? And here we sort of pretended it to be something that it quite wasn't, and that came back to sort of haunt us later. Well, sure enough, right? As we know, these continue on. They said, here's sort of the next best thing. Yeah, it's the asynchronous messaging style, right? Can we put all the different pieces together that we have learned and find sort of a way to connect the systems that manages to keep them in sync, that we can have an abstraction layer, that we can have them loosely coupled, right? And then it can be sort of at the behavior side versus just the raw data side. And it turned out, in some sense, that the answer to those requirements is a very simple style of integration, right? In some sense, think about connecting two systems. The minimum they have to do is like send data from A to B. And in a sense, that's all that messaging can do, right? But underneath, there's some very interesting sort of details and properties why we found out that this works particularly well. So the channels provide this important element of indirection, right? Like computer science is the field where everything can always be solved by one more level of indirection, right? So and the same is true here. Just like by putting one element in the middle, we get a little bit of decoupling. By making this channel asynchronous, we get also temporal decoupling, right? So the systems are no longer tied together sort of like they would be in an RPC fashion. The way we can interact with the channels is very easy and quick. Now we just put it in there and somehow it will get there. So, so all the details of that are a little bit hidden away from us. But in this way, it's not kind of a lie. It's actually sort of more the actual representation, right? The message really goes on there. And our expectation is that it's asynchronous, right? We no longer in this sort of RPC dream world where we think this is really a method. No, we understand this is a message that we package up and send on. So in some sense, you could say it's a little bit of more of an honest representation, right? So we had our wishful thinking for quite a while, and then we said, no, really, if you want to connect systems, you have to think about that. There are actually connected systems, and you cannot cheat your way out. And I think that's turned out to be sort of a very successful style. All right, there we go. So one thing that was very interesting in our book is that I think some of the best description about what messaging really is, or what are some of the key message advantages of messaging, are actually hidden somewhere in the introduction. And that was really a function of, when you write a book, you usually write chapter 1 last, right? Because you first sort of have to lay out all the knowledge and sort of get a feel for what's all going to be in the book. And then you need to sort of make a nice introduction that sort of motivate the material. But we had like 2 authors, right? So we couldn't quite agree what should go into the introduction, right? So Bobby wanted to really start much more from here's messaging and here's the good properties. I sort of at the time was in consulting. I wanted to come much more from the business perspective. Here's the use case, and here's sort of a company, a fictitious company that wants to solve some integration problems, and then sort of show step by step how the patterns help them do that. So I don't know, we must have had like long argument and battle, and in the end somehow I must have won. And I think it's probably because Bobby was on the East Coast, so he was like 3 hours ahead. So I could argue till like 1 a.m. and it was like 4 a.m. his time, and at some point he would just like pass out and like, okay, I get chapter 1. But then we put all the important stuff about messaging in the introduction. So in the end, maybe he might have prevailed, right? Because the introduction is before chapter 1. So he said, okay, then I just put this all in the introduction and I get my way also. So we have an introduction, I think it's 51 pages. It goes to Roman LI or something like that. So please read the introduction. There's a lot of good stuff in there, including, but not limited to, like what is actually really good about this stuff. So obviously, temporal decoupling and asynchrony is a great way to get systems to perform independently at their optimal speed, but still be tied together, still be able to communicate and exchange data. Throttling is another great property. Making a message and storing a message is relatively cheap compared to most other operations. So yeah, you can absorb traffic spikes, and you can process the data that comes in at your optimal pace. You can tune the system for a much more steady state, and the queue sort of absorbs basically sort of the peaks and the bottoms around it. It can be easily made reliable mostly because the expectation from the applications are so simple, right? They're just like, oh, I want to make a message and I want to get it to the other end. So the fact that underneath you have to store and retry and do various things doesn't really affect the programming model very much. So it's sort of very more reliable. And because you have the channels in between, so you don't really say send a message from A to B. You're really saying the message goes on this channel, and sort of B might pick it up if it so wishes. It makes it very easy to interject intermediaries. So rather going from A to B, the message can go A to router, transformer, all the other components we have, and then to B, and the sender would actually never know the difference. And then so the last aspect that is interesting is there's some interesting papers or analogies people have made. So it's throughput over latency, right? Like usually these systems are optimized for having a consistent and high throughput. And this is a little bit, if you're in a traffic jam, wider lanes are a good thing, faster cars not necessarily, right? So that's sort of a little bit the analogy of throughput versus latency. Now, of course, one size does not fit all. I'm not here to say messaging solves all and every problem in computing. But I think it's good to understand sort of the properties that it brings, and that can help us apply it to the right use case, and then more likely than not, we'll be happy with the way messaging actually does. So now, of course, there was a number of companies who realized this. Essentially, we just harvested the pattern. It's not like we invented any of this, right? So at that time, I was in consulting, and sort of like working with a variety of vendors. So I dug up the Gartner Magic Quadrant of integration and middleware from 2001. So sorry, Sanjeeva, like WSO2 is not yet here. Actually, I'm sure it's in the back of his mind somewhere, right? He's sort of forming at this stage. Actually, to be honest, there isn't really much open source here at all, right? So that is one thing that is interesting, how far we've come that sort of like open source in this integration space. Now is we sort of almost take for granted, but sort of how much work that actually took to say open source is a viable alternative. It's not like this is loosely or sparsely populated, right? There's quite a good number of players here, and they all had quite reasonable offerings. Sort of how much energy and work it would actually take to tell somebody, hey, no, we're doing this in an open style. The other thing that's interesting is, most of the guys that are sort of in the upper right-hand quadrant are actually still around. I mean, TIBCO is, alive. Well, last time I checked, IBM was doing, reasonably well. Vitria is still around. Then Cbeyond went to Sun, right? So they had a sort of little bit less happy, somehow Sun always had sort of the habit of acquiring companies and sort of throwing away all the good things and keeping the bad parts a little bit. So I had a feeling that's a little bit of what happened to Cbeyond. I think technically it's still alive. It's sort of the OpenESB/CAPS, but I don't think it has a very, very strong following. And then, where did Web Methods go? Software AG? Yes, they went to Software AG, right? This is interactive, right? It's not like I know everything, so I need some help from the audience here. I will be asking some questions. So the good news, I mean, it's been sort of like 10 years and going, right? And sort of usually the half-life of knowledge in our field is shorter than we wish. Like Mohan reminded us yesterday, like we reinvent everything like sort of every few years. The fact that sort of after 10 years this is still going must really mean there is an underlying value proposition, and this stuff does something useful, and it does something people actually want still 10 years later, right? So I think that in a sense, it's sort of somewhat satisfying to look back and say, hey, we've really sort of, in some sense, changed this playing field with a lot of the open source and ESB, but on the other hand, also, some of these guys managed to last through this. So the use case is definitely still there. So one thing that was amusing to me is sort of people actually managed to have some fun with all these integration tools. So this is actually TIBCO Integration Manager, where somebody went out and used the little activity symbols, and they had some sort of drawing contest, right? So it wasn't all necessarily business. Sometimes there was time, to have a little bit of fun. Actually, one thing I wanted to mention. Let me go back here. So I didn't promise this is 100% linear. It's somewhat asynchronous and loosely coupled here. So I reserve the right. It's not transactional, right? I can always go back, right? So one thing that was really interesting to me here is sort of in some way, what we set out to do is essentially solve the problem that we have these fragmented systems that each have a different representation and speak a different language, right? So there was sort of, in a sense, like the Tower of Babel problem, right? All these disparate systems. And the whole premise here, which largely has been fulfilled and been very successful, was to resolve that and find more common representations, couple the systems, get them to talk to each other and exchange information, et cetera. But if you sort of take a step back and look at how this was done from the industry perspective, actually, they created a whole new Tower of Babel. Now it wasn't the Tower of Babel of sort of the individual systems that wanted to be integrated. Now it was sort of the language and the tools they used to solve the problem, right? So basically it became sort of the Tower of Babel problem of sort of the next level down, right? It's all these tools, they all had their terminology, they all had slightly different, there wasn't really any standard, et cetera. And essentially they created sort of, they moved the problem sort of one step down, which was good for the customers in some sense, because the core problem of integrating the systems got solved, but it wasn't very good for the developers because we found ourselves with exactly sort of the same problem that we had on the business side just before, where the TIBCO people couldn't talk to the Vidya people and make any sense really much out of what each other were saying at the time, or you couldn't move anything from one tool to another tool, right? So at the meta level, you were like basically stuck where you were. So that was part of the motivation for us to think about, hey, we need to make a language, and this is the language for engineers, developers, analysts, et cetera, to talk about how we make these solutions that sort of abstracted out of the nitty-gritty detail that each of those tools has. And then we went about to say, like, okay, to make this work, what are sort of all the pieces you need to sort of make sense out of it? So first you need to transport messages, right? Like, if you can't send messages, there isn't any messaging. So that was somewhat obvious to be there. So in order to send messages, you need to like think about what your message actually contains, right? Like what should the message be structured like? And there's maybe some metadata and some data and control data and sort of all the kind of things you want to package in there. Maybe some of the semantics you like to choose. So that is sort of next step. Then the message has to get to the right place. And we said, oh, location decoupling is one of the nice properties. So we can route in between. And we don't have to hard code in the first application to think about where it actually goes, but instead we can sort of do the routing in between. Then, more likely than not, the formats won't quite match, so we want to do some transformation or maybe extract some information, et cetera, enrich with some other data so that the communication actually can be a high-value communication. Then, of course, the applications which live largely sort of in the land of object-oriented classes, runtime, JVMs, whatever have you, they somehow need to connect to the system which is quite separate. So there's the whole idea of producing and consuming messages and how that should work, right? How do you get a sort of very low latency, object-oriented, synchronous kind of program to talk to sort of an asynchronous distributed system? And then last but not least, because now the runtime takes on a lot more tasks, we also want to understand much better what's going on in this runtime, right? So the monitoring and management now actually becomes sort of a much bigger factor. We said, oh, that's like a good recipe. Of course, we know a few things are missing, and I'll talk about these later a little bit. What about error handling and stuff like that, right? So it's always, there's always sort of a little bit stuff that didn't quite make the list, right? But we were like fairly content to like say, okay, that sounds like a good start. And that's really how the pattern language started, right? For me, it's very important to remind folks, we like patterns, right? So because it solves one of our problems, it's sort of a representation of a solution to a common problem. But a pattern in isolation really is only half the value, right? Really, the interesting thing becomes once the patterns live in a language and you can understand the relationships between the patterns. And actually, much, much later, a German company, I think Logica, so they made actually a very nice poster for us where they sort of rethought how all the patterns are related and they put it all on one big poster. That's actually something at the time that we didn't get done. So we were very happy to see other people thinking more about the relationships between these patterns. So the language aspect is very, very important. So I'm still in the past part here. So what happened? We wrote papers for the PLOP, the Pattern Languages of Programming Conference, which is still going. I think it's now co-located with the UPSLA, which is now called Splash, right? Is that right? I think they renamed. And it was actually two papers at the time. So Bobby and Kyle wrote a pattern more about specifically messaging, and I was coming sort of more from the overall integration side and enterprise integration patterns. Those papers are still available. You can go to hillside.net, plop 2002, and look at those papers, and you can sort of see like some of the early starting points of sort of where the patterns came out. And not long after, we actually had the first version of our website up. So I think if I look back, the one thing that we've done right, if I may say so, is really to share the content very early on. It's like, sometimes you go to the store and you see this book and it has, the name on it, and there's, this guy, and like, wow, this guy must be a real genius, right? Like, he knows all these things and wrote 1,000 pages, and it's like, wow, this thing is like the Bible or whatever. For most good books, that is not true, right? Most good books, it's very unlikely one person sits sort of in the basement and types like for a year and out comes, this miracle. It's almost always because they had a good team of contributors, reviewers, friends, they put stuff on their website or somewhere. People send an email and say, hey, that icon you use for the aggregator really stupid. You should use something different, which actually kind of did happen. And we did change the icon for the aggregator. But it's really about getting the maximum number of input. Being at this event, we talk a lot about open source and sharing. In writing books, it's no different. Just it's been done sort of a little bit undercover. But generally, I think the good works that we have are much more community effort. We had all the content out on the website. Now, because of copyright, we only have sort of the key parts, like problem, solution, name, icon, and picture. But all those are available under Creative Commons. People made like Visio Stencil and OmniGraffle and tools and whatever all. Basically, the more the merrier, right? You can use the icons and basically more or less do whatever you want with it. It's like Creative Commons with attribution, right? We always like to know people where it came from, but otherwise, you should use it in any way you came. So that's an important point where I feel like really we did something right. We were actually kind of worried about this. It's like, oh my God, we're writing a book. It's all our sort of secret knowledge, kind of thing. How can we put out on the website? Nobody is going to buy the book. Totally not true, right? Because of that, really, the community, we got attention. We got some sort of fairly high-profile folks, to help us out. And that, I think, made the biggest difference in sort of people actually paying attention to the book, right? Like writing a book, it's always, you have to write a good book and you have to get it in the hand of the right people. But those are somewhat orthogonal, right? There's a lot of good books which like lead a total shadow life, and then there's a lot of junk we buy millions of, right? But sort of the combination of the two is really what you want to get to. This gives you also like a tiny little bit insight where we started, right? So you can see I was coming very much from the sort of message routing. Oh, I think my battery here is a little weak. We came very much from the message routing side, so I had a pretty good idea what should go on there, sort of pipes and filters, right? There was a little bit on transformation, and actually the management part, sort of the control bus, the systems management, that was all there very early. And then you can see that we sort of basically merged in then the other half. Bobby had much stronger background in sort of JMS, APIs, tying this together with the application, what types of messages and what types of channels you want to have. And we basically sort of merged these two together, and then in the end ended up with the 65 patterns. So that's what happened. Like at Uppsala 2003, the book came out. Seems like, it's like almost just right now. It was like, I think, October or something. So we're going to have our 8th anniversary very soon. If you think I talk a lot, well, read the book. It's 185,000 words. So, so apparently we type more than we talk even. We would never thought this thing becomes 700 pages. And the book that is useful is the book that people read. So it's not like we're happy because we made a lot of money, because really on technical books you don't so much. But you want people to read your stuff, right, once you go through all the effort. So we were like very happy that I think we sold almost or roughly 50,000 copies now. There's a couple of translations out there and stuff. We thought if like we sell 10,000 books or something, that'd be like an amazing success. So this was way beyond our expectations. And sort of that's what I want to talk a little bit more about. The fact that the language in the book became a little bit of the foundation for a lot of the open source ESB products. It's really something we didn't anticipate at the time, but that is really something that benefited us in the book, and hopefully likewise benefited the industry very much. So that was really sort of very, very nice synergy, which at the time yeah, nobody could know. I mean, basically, the last chapter of the book is outlook on web services, right? It's like, oh, here's the future will come, which now seems quite dated, right? I think Sean Neville wrote that for us. It's actually very nice, but now it's almost like sort of a piece of history in time. So yeah, I think sort of the fact that the book provided a core vocabulary and credibility for the open source products to describe what is an ESB, what is this problem space. No, really, there are some common solutions here. You don't need to buy all these kind of proprietary things. I think that was very, very helpful, and that's something that made us very happy and something that at the very beginning we could have never anticipated. So we're very, very grateful, basically, for the industry making this all open and actually adopting this language. So here's another representation of the language, so that you can see the things I talked about. There's an endpoint, it needs to produce a message. The message has to have a certain structure. The message has to go on some channel of which there are multiple varieties. Then they get routed and translated, and then sort of ultimately arrive at the other point. And all along the way, there's systems management and monitoring. You want to know sort of where your messages are and sort of what's going on in your system. So the original idea of structure actually really retained, and that is still the key structure of the book. Those are the main chapters with some interludes with like bigger hands-on examples that we stuck in. But there's basically sort of the 6 core chapters is still exactly like this, which hopefully makes it easy to navigate the book. The book is fairly long, so it's not necessarily meant to be read cover to cover, especially now that some parts are no longer sort of so up to date. But it's still very useful to jump around because we're hoping sort of we made the structure very easily accessible. The other thing that sort of later came back as sort of being one of the strong parts of the book was the visual language, right? Sort of the little icons and diagrams that we made. And as I said, they also underwent some iterations, right? So they look better over time. So the aggregator used to have a big sigma, right? Because sort of like summing things together. And then we thought, oh no, it's much nicer to have this actually sort of the little blocks, like sort of multiple messages become into one message. But I think that's something that has worked quite well. And I'll talk later a little bit more about why we think that worked so well. So in some sense, we were a little bit smart, but we were also a little bit lucky in these things. Why this worked so well in the end. So what also worked well is sort of once we had this visual language, what worked relatively well is to stick these patterns together and describe larger solutions, right? You can like say, oh, here's like a splitter, and it splits the messages, and it goes on a pub sub, and there's multiple listeners on a pub sub, and they send messages back, and you aggregate those, or maybe you filter them, you transform them, et cetera, and you can sort of kind of chain things together. One thing we did recently, and actually I'm still trying to make this a bit more widely available, we made playing cards for the pattern. So we like basically printed a deck of cards where I think for economic reasons it's like only we chose 52 because that's sort of like a good size of a card deck. So we picked sort of the 52 most popular pattern and made like a playing card for each pattern which has the icon and the text. And you can basically play the cards and like lay out your solutions on your table or whiteboard kind of thing. I'm still just trying to figure out how to get this sort of, make it economical and easy to kind of distribute those and everybody can get a deck of cards. Because I think it's really fun to have these sort of, the composability, basically with little cards. And then sort of the proudest moment, and sort of, soon I'm wrapping up the history part here. Proudest moment, most of you guys should know this fellow with the interesting hairstyle. And he listed his favorite patterns book, and I think more by luck of alphabetical order, we're right next to Erich Gamma, the Gang of Four, and there we are with the enterprise integration patterns, cited by Grady Booch as one of sort of the most influential patterns book, and we're like, wow, so this is when it pays off to have your camera handy. You're just like, oh my God, so I got to take a picture of this. So, Uppsala, 2005 in San Diego. So that's sort of where we were, sort of some of the things that worked out well, and sort of some of the things that we did anticipate, and some other things, we basically sort of were relatively lucky. Okay, so I want to talk a little bit about the patterns aspect of it and sort of where things come from, right? We have to remind ourselves that the patterns aren't necessarily sort of very hard components in a sense. The patterns are meant for human-to-human communication, right? And they're meant to be a little bit fuzzy around the corner. So one of the things that's interesting when you look back at Alexander is to realize that the sketches are really sketches. You know, they're not a blueprint or something. It doesn't say, you know, this bed is 195 centimeters wide, long, and there's like a 2x4 wooden stud from this material behind, you know, in the wall. But it says like, oh, this is the general shape that things take, right? And then I think that is good to remind ourselves. It's meant to give us sort of a catalog of solutions, but they're not sort of necessarily rubber stamp solutions. They're more sort of structures or directions and want to remind us about the strengths and the weaknesses and sort of help us make our own solution out of these kind of pieces. But, you know, really the fact that it's called sketch, you know, is good to remember, right? It's not a blueprint. And then it's been a, you know, of course, those guys, you know, did this quite a little bit before we did. One of the nicest quotes around describing patterns, you know, comes from Ward Cunningham, who said they're really the mind-sized, you know, chunks of information. They're sort of the chicken McNuggets of knowledge, if you wish, right? It's just like sort of just enough to teach person sort of one little thing. It's like, no, really, you know, you shouldn't tie your, you know, classes together. You should use an observer kind of thing. And here, go read a little bit more and think about it, really. That's really what the patterns were meant to be. And I think sort of where I'm going with this, you know, this is, you know, important background to keep this in mind, right? It's about sharing knowledge. It's about, you know, human-to-human interaction. Now, in the software field, it's interesting because we can now think about, can we do more with these patterns, right? Like, can we make these components, put them in IDEs? And there have been some interesting cases, actually, where that's been very successful. So the real question is sort of, we have sort of the enterprise integration patterns. What else could we do with this, right? Is there sort of patterns 2? Is there patterns 3, patterns 4, right? Sort of what's coming next? And particularly, I want to look at sort of how it relates to mapping on the system structure or sort of what other kinds of patterns we could find. So if you think that you have a sort of a pattern to start with, I think there's a couple of dimensions in which you could expand. The one dimension, I think I'm really out of, well, there still goes, almost out of battery. You have to get closer and closer as the talk goes on. So the one thing is, you know, as I said, the pattern lives in its family, right? The pattern never lives in isolation. So I think building out the family and filling in the missing patterns is definitely something that is worthwhile. It's sort of unlikely that we found exactly the 65, sort of all of the 65 right in the beginning. They're likely to be more. The other one that's very interesting is to project more onto the platform, right? To talk more about, can we put this into tools or the runtime or something? So that is also very worthwhile, and want to chat more about this. And the other thing is, you know, broaden. Like, basically, we call this enterprise integration patterns, but really all we wrote are messaging patterns, right? They're bound to be many, many more whole useful, you know, pattern languages and pattern families in this integration space. So looking forward a little bit, so here's some stuff we played around with. So this is more around, can a pattern be a component, right? Sort of the deepen or the projection onto the platform. And this was a long time ago. This was actually something I played with where sort of I made a domain-specific language and said, oh, I can actually describe this solution, you know, literally with these kind of verbs and have the names of the channels, and it's actually executable. Like, I actually made a demo in, you know, so using MSMQ or something very, very simple, and each of them has like a cute little GUI, and you can wire these solutions together. And what was interesting to me was like, strangely, this worked better than I had thought, knowing that patterns are most meant to be sketches, not, you know, components or specifications. And it was sort of interesting to think about why this worked relatively well and sort of why it might be a good idea or not idea. And I think since then, you know, a lot of, you know, tools have actually gone this directions. So I still think patterns and components are apples and oranges, right? They're sort of, you know, two different views of the same thing. But I think for messaging patterns, we have sort of a relatively unique opportunity. So why they are different is really, as I said, patterns, you know, they're sketches, they're fuzzy, they're really for us to talk to each other. They're human-to-human integration, right? They're not system integration, the patterns. They're really, you know, integrating people and getting people to talk to each other. Versus the components are much more precise, executable, and usually dependent on a specific platform. The reason I think this worked so well in the integration patterns, or it's more possible than in most other environments, is because we use this very simple pipes and filters style, right? Basically, the composition model is super simple. You basically just, you know, connect the two things together with a wire, and the way they interact is actually super, super simple. right? And you could even think about formalizing this a little bit. Oh, there's input ports, there's output ports, etc. Input ports have to connect to output ports. So that's one reason it works well. The other reason it works well is because we can cheat a little bit and use other languages. So if I go back to the previous slide here, we can see so that this is /order/item thing in the splitter, and that is really a piece of XPath, right? So embedded another language in there to describe how my splitter can split the messages. So having these other languages available is actually sort of a very clever trick. Now, I think this is somewhat unique to the messaging style because it's so easily composable. This is probably something that we won't be able to repeat with other pattern styles. Like in the OO world, this did not work, right? Because the composition is much richer. You don't build systems and saying, oh, I have an observer here and I have a state pattern here. It doesn't work that way. So I think in that sense, we're a little bit lucky, and most of the credit, I think, goes to the pipes and filters style because it is so simple. So one way to think about, I chatted with Paul a little bit, sort of to go this direction is maybe what we could do is sort of have a spec sheet or some property sheet or something for each of those patterns to say, what are the remaining variability points, right? Let's say I want to make an aggregator, and then what else do I need to decide and start sort of making a list. Oh, I need to have some completeness condition. I need to have some aggregation algorithm, et cetera. So maybe that would be sort of a not too formalized or too rigid way, but to think about, how do I take this pattern to the next step? And then you could see that this is maybe not as far from tooling, right? You could sort of think about some of these properties could go into some runtime. What you do need to do is you do need to use the proper language for these functions, right? Like the correlation function maybe is XPath. Maybe the completeness condition is XPath. Maybe the aggregation algorithm is maybe some more procedural language. So you need to plug other languages in. But I think then you can sort of take this to the next step. The other way to think about, so this was about how the patterns can go deeper, right? Be sort of projected onto the platform. The other way to think about how we want to broaden the patterns is to go wide. So when you think about one of the questions that was often asked about the book is like, hold on, why is it called enterprise integration patterns, but it's really just about messaging? I say, that's because we have a very clever plan. Sort of messaging is sort of one part of enterprise integration, but there are certainly other parts, right? So there are messages are sort of stateless and travel through systems, but you find yourself easily in cases where you want to have a conversation, where messages sort of travel back and forth between systems. There's a little bit of state. As soon as there's a little bit of state, there is easily the notion that there are some processes that support that state, so there's definitely process patterns. And then obviously, we recently have a lot of success with complex event processing and sort of event-driven systems, and I think there's also a whole other family of patterns. Now, one of my challenges, I didn't really pay attention to when I really started, so do I really have 1 minute? I was told I get 45 minutes from when did I start? Anybody remember? 9:20. All right, so I have 7 minutes, right? Yeah. 6? All right. Oh, I didn't know that. All right. So, yeah, so let me talk a little bit. I don't want to blast through the slides and then it all becomes a big blur. So let me pick some of the highlights, right? So this is exactly where we are with our thinking and saying, are there sort of other patterns? And the short answer, there is, and I think this is sort of right now my mental model, sort of messaging is the first one, and then sort of conversation, process patterns, event patterns come. The one we have done most of the thinking is that messaging itself is stateless, and that gives us a very simple elegance, but it also keeps us from talking about some interesting topics, like error handling, for example, right? Because most of the time in error handling or compensation, you need some state, you need some condition, you need to know where you are. And basically, we didn't have any of the vocabulary in the book, and that's why that never made it, or the sort of more complex interactions. And that is really what the, a cute animation here, wow. That's where the idea of the conversations came in, right? Can we take a very different viewpoint of the system, and rather having this chain of stuff, right, this free flow, can we say there is a set of systems, and they have some state inside, and they exchange messages over time and sort of corresponding to the state. And if you think about BPMN, et cetera, these are certainly elements that are in there. And I think that will give us sort of much more vocabulary to talk about sort of where the conversation stands, what the rules of the conversation are, sort of the different valid route of the conversations, contracts, etc. So if you're thinking about message exchange patterns, that is definitely in this space. And I want to think more about sort of what kind of design patterns are actually in there. So that I've done actually, I started quite a bit of work. I think I have a little bit, I have some examples here. I know people always, it's always mean if somebody skips slides because, there's all this good stuff, but he's not telling us about it. But it's really their fault. No, it's the traffic's fault. It's like, we were late. No, but what I wanted to talk about is sort of where I am at with this, right? So I collected a number of different patterns, and you can see sort of on the right-hand side where there's really conversations, like request, reply, right? I'm sending a request, I'm getting a reply back. I might retry, subscribe or notify. Somebody might send me a message that they want to be from now on notified of things I do, and they might unsubscribe, or the subscriptions can expire automatically, or they have to be renewed over time, right, because we don't want to be too much coupled. So those are the kind of vocabulary I'm thinking about, up to sort of a little bit of negotiation contracts, so like tacit agreement or reaching agreement. So tacit agreement is basically, if I send a message out and nothing comes back, I assume the action to have completed, right? So it is negative acknowledgement, basically. And as with most patterns, most of these things are implemented in underlying layers, like networking and IP, et cetera. Many of these things happen, positive, negative acknowledgement. But I think bringing these back to sort of the level of where we talk about messages and system integration, enterprise integration, I think there are still very, very many interesting use cases. And I started writing on this like about 4 times. I'm still trying to think it's going to be a book, but it's been very, very slow going. So I have some papers and things out there that I workshop. And then this would be the lay of the land of the pattern family of the conversation patterns. One of the biggest challenges has been, besides actually getting the energy to finish writing this, one of the biggest challenges has been I haven't found as good a notation. Like the cute little diagrams, the pipes and filters, they worked really, really well. Conversations are richer. They're not as easy to describe, right? They're sort of the UML2 sequence diagrams, but they're not sort of very intuitive. So it becomes harder and harder as you go up the stack to find a sketch, to make a sketch which is not a blueprint, but actually something where somebody can look. It's like, yeah, I get the point, right? I get the essence of this. So that's roughly where I am. We've had very interesting discussions around this. So you can see how some of this started. I always like to show the history, right? So here's on the whiteboard, and we have here sort of these different kind of interaction where you place an order, you get a quick acknowledgement, then you get a confirmation. And this was actually at a Darkstool workshop, and you can actually see some of the guys who contributed to some of the ideas. And you can also see sort of what the core element of contribution is here. Sanjeeva is sort of proudly holding this in his hand. And probably this is a good point to wrap up. To think about, there's the overall enterprise integration patterns. Messaging is the foundation for it all, but it's very elegant, but it has sort of its boundaries. And now I'm thinking much more about how can we tackle the next layers, right? And to me, the next layers are really about conversations, which is still very close to messaging, but has some state. Then probably sort of workflow patterns where we're sort of much more looking inside the systems and the state they have. They're, of course, very closely related, but I think there's different patterns. And then sort of lastly at sort of event-driven, complex event-driven patterns. Now, whether this is ever going to be like sort of a life work of 4 volumes of books, I'm not sure, but at least sort of, that is my vision where I want to go. And essentially, the more people I tell about it, the more committed I feel that I actually have to go and deliver. So please feel free to sort of nag me and ask me, hey, when is it going to be done, when it's going to come out? Because maybe I'll feel more guilty and actually sort of keep working on this. So, well, thanks for listening. I hope this was interesting. Thank you very much.
We'll take 1 or 2 questions, quick questions right now. Yeah, Srinath, can we get a mic?
So I was like involved with the project where we'll do a lot of visual composition and data flow language, etc. So after that, like especially when I first joined WSO2, etc., whenever you see visual composition, data flows, I was jumping around and trying to do that. I mean, on that project, it worked out great, but I mean, when I started looking around, I kind of realized yes, everybody get excited when you see visual composition and data flows, but it isn't very successfully around yet.
Yeah, so
what do you think?
So I think that, so I have two thoughts. I think, I mean, I like pictures, obviously. I like, visual style, as you can easily tell, from the book. So one thought is that actually programming in pictures is something that makes very sexy demos, or very nice demos, but it doesn't scale very well, right? So for complex solution. So if you want to use it for actually as a tool to create something, it's very, very important that the tool can navigate very easily, or that you have some easy ways to encapsulate it. Like you must be able to sort of zoom in or open pieces and close pieces. So some composition model is very, very important. If you're trying to make sort of this proverbial huge picture, we all know that from the enterprise data model, right, where everybody plotted this huge thing, it was very impressive, but not necessarily all that useful. So I think there's more that has to happen to make the interaction with the tool much richer for this to work for the creation side. In the meantime, I think using pictures not actually to create things, but just as a different view can be immensely useful. And I've played with that quite a bit. So you might still be coding in XML configuration or Java or whatever API you have, but because there's a lot of configuration, right, and there's sort of a lot of runtime decisions, going back and sort of revisualizing that, I think that has sort of equal value. And I think in the short term, that is somewhat easier to realize. Getting people to program in pictures, it's a mixed blessing. It can be tough, but getting people to see pictures is almost always a win. So that's what the control bus, for example, can do, right? It can harvest, like, where do my messages really go? Yeah, which queues are full? Yeah, what's going on? Yeah, use GraphViz to actually draw my message diagram. And I did quite a bit of that work, and I've been fairly happy. So my recommendation is, in the near term, you focus on the representation side, right? And sort of in the background, think about if you want to get people to program in pictures, don't just sort of make a big white canvas and they plug symbols on. That's most likely not going to cut it. You really think about some very rich environment that's very fluid, where people can look at things from very different angles. And I think that will take some time. So we shouldn't expect that to happen this year.
Thanks,
but it's fascinating. I'm very interested in this as well. So one more, maybe?
Just one more, yeah.
One short question and a short
question
answer.
over here. That's it. Thank you.
The trick is the short questions usually have the longest answers, right? It's always the dangerous ones, right?
So. Gregor, is it audible?
Yeah, I can hear you. Yeah.
So the question is long, so you can give a short answer, maybe. So I've been having thought this, patterns are everywhere, right? So it's not just in systems. It's also relevant for societies and the universe. So what's your thought about writing a similar book on integration of societies?
Of integration, what, sorry?
Societies.
Oh, yeah. So that has sort of the social aspect in it, right? Yeah. So maybe I should go work for Facebook or something, and write some patterns. To me, the interesting part, I mean, all joke aside, is we have to realize, like, most of the good ideas these days come from people pulling different pieces together. So it's relatively rare that somebody has sort of one original idea that's just like one new amazing thing. That happens every couple of years, and usually there's a big research team. So when we think about patterns or the way to represent ideas or describe ideas, I think pulling from different domains is actually very, very useful. And I would say the best example, and I wouldn't claim this is quite as far as sort of society, is, many of you might know I have this little article called Starbucks does not use two-phase commit, right? So you can easily find on the web, just search for Starbucks two-phase commit. There isn't really much else out there. But the message I wanted to send with there is really that when we think about system design and these kind of patterns, the real world can actually teach us a lot about good system design. And so that Starbucks was a little bit tongue-in-cheek, but I think when you think about loosely coupled systems, or especially the conversational patterns, I think they have a lot of analogies about how people actually talk to each other, how people communicate, because human beings in our environment is asynchronous, unreliable, right? It's sort of very state and context driven, right? So all these attributes are actually in there. So I think, to me, I don't think I can necessarily solve their problems, but I really want to harvest from the ideas from those domains and bring those into